Alright, here's a little tutorial on how to solve for the launch velocity of a horizontally launched projectile. So here we go. So when you have an example problem like this, a ball is launched horizontally from the top of a building that is 35 meters tall. If the ball lands 25 meters from the base of the building, how fast was it launched? The first thing you're going to want to do is kind of draw yourself a little picture of the situation. We have a building, ball coming off of it with a velocity, and it's a certain y distance up, and it's going to come flying over, and it's going to land a certain x distance in this direction. Now, since we know the x and the y direction are completely independent of each other, I'm going to make my little t-chart. We have the x direction, we have the y direction, and they are separate. So, the ball is launched horizontally. We don't know what that is. That's what we're looking for, how fast it was launched. So we want to know the velocity on this side. We know it lands 25 meters from the base, so that's the distance or displacement on the x direction. So that's our 25 meters. And the 35 meters tall, that is the displacement the ball travels in the y direction. And since it's traveling downward, it's falling. The building is 35 meters tall, so the ball travels a negative 35 meters. And we know that since it's thrown horizontally, the initial velocity in the y direction is 0 meters per second. And we always know that the acceleration in the y direction is little g, which is a negative 9.8 meters per second squared. What we don't know on either side is the time. The time is our question mark on both sides. So we notice that over here we have an unknown and another unknown. So we have two unknowns on the x side, but we only have one unknown on the y side, and these two are the same thing. So let's use the y side to solve for our time. So we're going to use the equation delta d equals v naught times t plus 1/2 our acceleration times time squared. Alright, and in this case our v naught, since our v naught is 0, that whole term disappears, and we're left with simply delta d equals 1/2 gt squared. Well, if I'm solving for time, let's move this over a little bit. If I'm solving for time, then I need to multiply both sides by 2. So that gives me 2 times delta d equals gt squared. And then I divide both sides by g to get 2 delta d divided by g equals t squared. So my time is the square root of 2 times my displacement divided by acceleration due to gravity. So now if I plug in the numbers from my problem, my time is 2 times 35 meters divided by 9.8 meters per second squared. And technically that's negative and this is negative, but since the negatives cancel out, you can ignore that. And then I do the square root of all of that to get my time. Whenever I do that, I plug it all in my calculator and I get an answer of time equaling 2.67 seconds. So I wrote it over here on the x side because the time is the same on both of them, so it doesn't really matter whether I use the x or the y, or write it on the x or the y side. So now if I want to know the velocity of an object is its change in distance, or its displacement, divided by time. So I simply plug in the numbers. We have 25 meters divided by 2.67 seconds, and that gives us a final answer for our launch velocity of 9.36 meters per second. So that is how you calculate the launch velocity when all you know is the height and how far it travels.